Hello, my name is Silvano. I work on Postgres in Microsoft Azure, and I'm here today to talk about .NET and Postgres as the next open source application development stack for your solutions that can run on your on-prem, cloud, mobile, and many other platforms, and interacting maybe with the next gen AI models that Azure is providing. Okay, so let's dig deeper into this very vast subject. By the way, here you can find my social media handles. Please follow me if you want to know more about this subject, because I'm going to publish a specific series of videos on this particular topic. This is going to be just scratching the surface, but you will see a lot more. I've been working on various roles in databases over the last 30 years, and I have a lot of experience in application development and database design. And this is where, I actually found that I think it was interesting for me to present you about this subject. Because .NET is a great platform. It's a almost 25 years old platform, and over the last 10 years, .NET has been open sourced, fully open sourced, and the support for other platforms for cross-platform development and runtimes on Linux, on Mac OS, and other operating systems have been introduced. So why .NET? In reality, again, .NET is an application platform you can use to develop applications and solutions of all sorts, from in cloud to desktop to mobile apps, IoT apps, and also more recently to interact with large language models directly from your application code using a variety of frameworks. It offers a bunch of tools. Some of them are proprietary, like Visual Studio, running on Windows, but there's a wide variety of open source tools like Visual Studio Code, most of the CLI commandlets, and a bunch of tools in the ecosystem, frameworks like .NET Aspire, and we will see specifically how this can help orchestrating, deploying, running distributed applications. And in terms of operating system support, we're going to focus specifically on Linux, although .NET can run, as we know, on Windows, Mac OS, and actually a bunch of other operating systems as well. So when we are developing our apps, we also need to consider the entire development loop, right? So starting from local development, again, .NET is supported on Windows machines, on Linux machines, and Mac OS machines. And we can actually run directly on the native operating system or containerizing our solution. So if we are on Windows, for example, we do have the Windows subsystem for Linux that is helping us to basically create and develop applications on Linux, although we are running on Windows. On Linux natively, of course, we can use tools like Visual Studio and create containerized versions of our applications, interact with Postgres, and at the end, we can either leverage CI/CD environments like GitHub, where .NET is fully supported across repositories and across the action pipelines, so that we can deploy out fully automatically on whatever target, like our own on-prem data center, Azure, or other clouds, using basically the automated capabilities of these CI/CD environments to both provision resources like Postgres instances and our application code and containers. So we're seeing that .NET can natively run on Linux. So let's see a quick demo on how we can install .NET on a brand new Linux instance just installed. Let's install .NET on a brand new Debian VM here. We can notice .NET is not here yet. And if we look at the details, we notice that this is an ARM64 processor architecture. So .NET is not available in our default package manager. So we need to use the scripted install and the .NET install tool. Once downloaded, we change the permissions to execute, and now we can install a specific version and a specific processor architecture of .NET in a fully automated manner. Once this is fully downloaded, Let's wait a few seconds here. And now, again, we notice that .NET is not yet in our execution path. So what we need to do is to fix a couple of environmental variables here, .NET root and our path, and all of a sudden .NET is available on our machine. So we can just test a new console app here called test.net, and we can see that the application is effectively running once compiled. And now we can actually start installing our tools and every other library that we need. Okay, so it's that easy. Actually, .NET comes installed in and prepared in all the official distro package feeds from a variety of Linux distributions. So Ubuntu, Red Hat, Fedora, Alpine, and in this case, .NET packages are basically loaded into the official package feeds. But there's also the Microsoft package feed where you can find .NET packages for pretty much every Linux distro, including Azure Linux 3.0, which is a Microsoft specific distro, fully curated specifically for the cloud. But there are also other ways of deploying .NET on Linux. If you are a Snap user, there are Snap packages there. Or, as we have seen, there are scripted tools that can install .NET on pretty much every processor architecture, not just x86 or ARM, but even PowerPC, RISC, and like S390 on mainframes. Once .NET is installed, again, we can develop our apps pretty much on every desktop operating system. So if we have Linux and we are using the Linux desktop, we can use editors like VS Code or many other open source editors. If we are on Macs, just remember, Mac OS is not Linux, right? So we need, if we want to target Linux environments, we need to either use a VM, like Parallels, for example, in Mac OS, or any OCI compatible container host, and develop our app targeting Linux. And then using VS Code, we can actually leverage tools like the remote development extension to connect to our containers or our virtual machines remotely and develop as we were effectively developing on our own operating system. Okay, it's very much likely that, again, when we are developing our app, we want to package them into containers in order to make sure that we can consistently developing and deploying on every machine without any problems related to specific libraries or environments that we have configured. So let's see in the next demo how we can create .NET containers and run them on Linux, both using Docker tools or other like OCI compatible framework, or directly from the .NET command line. In this second demo, we are going to talk about .NET and containers as a way to consistently build and deploy our .NET apps on Linux. After being installing .NET, now we can actually leverage also some of the tools that we have available on this platform. And specifically, we're going to talk about VS Code here. So we're going to launch code in this project. And we have a very small .NET app here with just one single file. And in this app, we're just going to print out some operating system information and some .NET Framework informations, right? And what we can do here right now is to go ahead and build our app and to actually run it. And we can see that we are running on Debian 12 on our ARM64 platform and with .NET 9 and runtime for Linux here, right? So what can we do to actually containerize this app? So we do have the Docker extension installed here, and with that we have a bunch of tools. Like, for example, if we do Control-Shift-T, we can add a Docker file to this workspace to basically containerize our app. And if we select this, you can pick up the different application types. .NET Console is great. Linux is our target, and we don't want a Docker Compose for now. So right now, basically, the extension has created for us the full Docker file where we are pulling the runtime image here, we are pulling the SDK, building the app, and after that, we are just publishing and copying the final bits in our target image, right? And what we can do right now is just to basically invoke the Docker CLI command and build our image, which is going to be called Docker container, tagging as ARM64, and selecting the platform as ARM64, as this is basically our target machine. Once this is built, we can notice that we have the new image created. We can actually run it. And this is just running as expected. As you can notice here, the .NET version is slightly different because this is the latest available in the base image that we've been using to create this. What is interesting is actually using the same platform here. We can also, like for example, build for a different target architecture. Like for example, we can do AMD 64 and target our image differently. And we can see now, we now have two images, one for AMD 64 and one for ARM. Of course, if we try to run our AMD version here, of course, it's giving us a format error because this is targeting a different one. But what about if we don't want to learn Docker and all these different complexities? Well, the .NET CLI now has also integrated into the .NET Publish operation the creation of a container image. Now we are actually doing this and targeting Linux and ARM64, compiling as a release and publishing as a container and tagging this container with a given tag, right? So if we are doing this, we can see that .NET itself is basically taking care of not only building, but also publishing the container. And if we are looking at our images, now we also have, our Docker image here, and we can actually run it as, the previous one with the ARM64 tag, and it's working exactly as expected, right? And again, even with .NET, we can actually do cross-platform compiling and image creation. And here we go. And now we're gonna have the different platforms are supported here. But what we're going to do here is we're going to actually run our container, ARM64 container in the cloud. So if we want to run our AMD image in the cloud, first of all, we need to tag it for our remote registry, and then we can actually push the image, local image, to the remote registry. So this is pushing, and once it's created, what we can do here is now to use the Azure CLI commandlet to create a new container instance with a name and a resource group and pointing to the image that we just created on our repository, and sizing the number of CPU V cores and the memory. This is 1 GB and 1 V core. Then this point we just need to basically provide Azure with the credentials to pull from the registry. And once this is done, Azure is pulling the image, and after a few minutes or seconds, is going to give us the new container which has been created. We can check it with the Azure CLI if the resource has been created. We can see, yeah, this is the name, and we can actually connect to that container and look at like the output, which is in the logs, and we will see that basically the application here we are is basically outputting the same information. So Debian 12 now it's on a AMD 64 image, and these are the .NET runtime information. Okay, so what we're seeing here is we can start by Dockerizing our application thanks to the Docker extension in VS Code, or leveraging the .NET Publish capabilities of creating a Docker container. And then we can run the container locally, or we can push it to a container registry and run it everywhere in every cloud that supports a Docker container in their hosting services. And running Postgres in containers together with your applications, .NET applications on Linux, is very, very simple. And in this demo, we will take a look at how we can package all together and run your application development locally or remotely using containers. In this demo, we're going to bring .NET and Postgres together on Linux, and we will see how containers are actually playing a role here. So let's open up VS Code, and I have a very small project here, which is actually an API, ASP.NET API, right? And project is actually very simple. Is creating, first of all, the application builder here, and is doing a setup of the database, and we will see how this is configuring the database for us. And then it's basically exposing one endpoint called customers, where we are leveraging the NPG SQL library, which is the official .NET ADO provider for Postgres. And we are creating a new connection, and we are creating a new command, which is just retrieving old customers from the schema sales. And then we are executing the query and iterating around all the returned results, all the rows. And for each row, we are creating a customer object, adding to a collection and returning as a JSON result set out of my web API invocation. Right, so the application is actually pretty simple, but I don't have Postgres instance to deploy on my own machine here. So what I was doing, I actually created a Docker Compose file here. And the Docker Compose file is made of two different services. There's an API project here, and there's a DB project. And the DB project is referring to an image called Postgres latest, which is polling from the Docker public repo, is polling the Postgres image and is configuring some environmental variables here for setting up a user password and DB name, is exposing a port, and then is also checking that the deployment and the ramp up of the Postgres progress is okay before returning okay to the API project. And the API project is basically just using the image created here with this Docker file, and which is building, as we see previously, our app into an official Docker image for .NET, in this case for ASP.NET. So what we need to do here to make it run is simply to say Docker compose up, and this is pulling the DB image from the public repo, is also pulling the API, is building actually the API app and the related Docker image. And once this is done, we should see in a few seconds that here we have the Postgres log showing up here together with the application log. So the application is listening on port 8080. So let's see if here we go. And this is basically the result set coming back from the database and returned as a JSON fragment. We could also have tested here using the .http file created by the .NET template, which is giving me the ability to test it, to test my API directly from my VS Code instance. So if I click send request, we can see the response right here. Right. So let's take a look at our code here for a second and go back to this setup DB code that we have and the perform upgrade. Those are important ones because they are leveraging a library called DBUp. DBUp is an open source library for dealing with change management in my database. So at first, what DBUp is doing is making sure that the database exists. So I'm passing a connection string, which is here in my application settings for the development. And so what the DBUp is doing is checking that this database Postgres effectively exists. by connecting with my Postgres instance and running a query on the system views in Postgres. After that, the DBUp, what it's doing is deploying changes to this database that we are that we are connected with, and is basically reading scripts from within this app. And the scripts are here in this folder, which is actually pointed out, as we can see here, in the project file, where I'm just saying, hey, scripts are just embedded resources in my app. So let's see what the scripts are doing. First of all, the first script is just creating schema called says, and the second script is creating all database tables and is also inserting some reference data in those tables. So by invoking this deploy changes and the perform upgrades, the DBUp library is checking that those changes have not been previously applied by using a system table, which is taking notes of all the executed operations on the database, and then it's just performing all those operations that we are seeing to make sure that my database is ready to go when the application is connecting. So basically, this is a way to prepare our database and make sure that we have a consistent database state to run our application against. And if we connect with my local instance here, here we go. We can see that we do have our sales schema with all our tables. Right, let's pick up the customers table. And here we are. So we are running Postgres on a local container using Docker Compose together with our app. And our app, when it's starting, is basically checking that the database is fully configured, the tables are there, and all the data are ready for my application to run. So this is just a way we can interact with our local development here using Postgres on containers and using .NET on our app. From your .NET app, how we are going to access .NET is through the npg-SQL ADO.NET provider. So npg-SQL is basically the .NET data access library for Postgres. It's 100% managed code, C# code. It's actually maintained by a number of developers from the .NET data team itself, and is supporting Postgres WAI protocol for applications running in .NET using classic paradigms like connection, command, result set, and so on. The other option to access Postgres from .NET code is using Entity Framework. Entity Framework Core is a fully fledged ORM, and means that you can create your data model in code. You can access your database and have all your code operations translated to SQL, and your result sets basically hydrated into your object collections in your code, and you don't need to deal with specific SQL syntax or such on yourself. Entity Framework is also managing all the life cycle of your database using migrations, a pretty well-known concept, where you can basically generate your database objects from Entity Framework, update them, maintain them, and so on. So ADO, plain ADO.NET or Entity Framework are the way we are connecting to Postgres and executing our code. So let's take a look at this demo and see how we can connect to the database. In this demo, we are using now a web app instead of an API app, and we're using Entity Framework Core to connect to the database. So we can see we still have ASP.NET middleware creation here. So we are creating the builder and so on. But this time we are actually using a DB context. DB context is the main class in Entity Framework Core for connecting to the database. And we are using the new seeding capabilities to actually kick off population of the database and the preparation of the database, actually using Entity Framework migrations before that. So let's see what we can do for actually getting Postgres instance first. So I actually created this command here for kicking off a brand new container, right? And so container is now up. We can connect to that instance. Let me see. Okay, and we have the Postgres database here, but in our demo this time, we're going to use actually a different database called SAIS, right? So we need to initialize the database. We have two ways. One is manually by using the .NET Anti-Framework tool and invoking basically the migration of the code first classes here into the database, and then the basically insertion of the reference data. Or the other way around is to actually let the code the first time it's running to do that. So let's go with the Entity Framework migrations now. So we can see, we can use the same .NET CLI here and say EF, which is the Entity Framework tool, database update. So what this command is going to do is basically taking the schema, creating the schema of the database, and then inserting all rows. Right. So here we go. So now if we connect back to the database and refresh, we have the sales database with various tables, and let's see the customers table. So now we can just test if our app works correctly. And this is a homepage of our web app, which is actually reading data out of the database. And if we go back and take a look at our console here, we can see all the database insertion and preparation operations that we saw previously. And then when the application is starting, we can actually see the logging of our Entity Framework query, which in this case is a simple select out of the SAIS or out of the customer tables in the SAIS schema, and the execution. And this is, again, we haven't actually written any SQL code. We can go and take a look at our code in our main page. So if we go to the index page here and we take a look at the code, we can see that what the Entity Framework syntax here is doing. I'm just taking the context that we previously declared at the beginning of the creation of our ASP.NET app, and I'm just asking for all the customers within the table, in async manner, and then we are basically using this customer collection. Here we go. We can just use this collection, iterate, and create our HTML, generate our server-side HTML. Right? So this is actually a different way of connecting with the database. We don't write down directly SQL queries, but we are using Entity Framework as a fully fledged ORM to connect to the database, interact with tables, insert, update, delete, and retrieve data. Okay, so .NET Aspire can help us orchestrating our application deployments. In Azure specifically, there are a number of hosting services where we can actually deploy Linux containers, depending on the scale and the size of our applications. Starting from Azure Application Services, where typically small web applications and APIs will get deployed, to Azure Kubernetes services, where more complex and distributed applications can actually be deployed, or deploying individual containers using Azure Container Apps and Azure Container Instances, right? And a bunch of other services, right? So Azure is offering us all the native PaaS services where we can deploy our apps, and is also offering us a fully managed database service called Azure Database for Postgres Flexible Server, which is, by the way, running on Linux containers in Azure. So you can see here a quick glimpse of the architecture. Postgres is actually running as a container within a Linux VM in a fully automated manner. Is leveraging Azure Storage, specifically managed disks, for storing data and the wall log, and is managing high availability, scalability for us, right? So if we think about what we've seen in the demo, we can deploy our .NET code in different hosting services, from VMs to web apps to Kubernetes, and we can target our managed Postgres service, which is again running on Linux container. So we are running on Linux end-to-end from our application code to our database backend code. And .NET Aspire is a great tool and a great resource for this, right? It is helping us during the local building and testing, and using the orchestration tools is basically helping us to deploy seamlessly from your desktop to the cloud or to any CI/CD pipeline environment like GitHub Actions or Azure DevOps. So it's also giving us some interesting tools like our developer dashboards, where we can see all the components in our app. We can see how various components are integrated. It's taking care of injecting things like connection strings, environmental variables, and all the other settings, taking care of all this complexity for us. Is also exposing all telemetry data built on top of OpenTelemetry standards, so that we can debug, trace, and understand how our application is running. And it's not just working on Azure, it's actually working on any cloud. So to recap, .NET together with Linux, running in containers, and Postgres are the best environment for developing your applications in Azure, but also on other clouds, and is clearly providing you like an end-to-end environment here where, again, it can simplify your inner loop and your outer loop, and all the release activities in order to publish and run your applications in production. Right, so this end-to-end tool is fully open source, as we've seen, is basically free of charge from a licensing perspective, and can be the next application stack where you're running your applications. If you want a very interesting reference architecture and application, I would recommend you to go to github/.net/eshop, where you have a fully fledged e-commerce-like solution, fully running on containers, .NET, and Postgres. And you can take a look on how you can not only develop simple apps, but also complex distributed apps interacting together using caches like Redis, using queues like RabbitMQ, and also interacting with OpenAI language models in order to provide like assistance, an intelligent chat for your own users. So please take a look at this reference architecture because it's very, very interesting. Okay, so that's all for today. I just wanted to give you this quick introduction about .NET, about Postgres, and how to run this all together using tools like .NET Aspire on Linux and fully open source platform. Thanks again, and please keep an eye on my social handles because I would publish more about this topic soon.